October 14, 1942, 28,000 feet above the English Channel. Hauptmann Heinrich Bär squeezed the trigger of his Focke-Wulf 190, watching 20mm cannon shells streak toward the formation of Boeing B-17 flying fortresses 300 yards ahead. The new MG-151/20 cannons mounted in his fighter's wings fired at 800 rounds per minute, nearly double the rate of the older MG-FF cannons they had replaced. What happened next would fundamentally alter Luftwaffe understanding of what constituted effective bomber armament. The first burst of shells struck the lead fortress in the port wing route, exactly where Bär had aimed. Instead of the usual handful of hits that previous cannons might achieve, the high-velocity shells tore through aluminum skin, severed control cables, ruptured fuel lines, and continued through the aircraft's structure with devastating efficiency. The B-17's wing folded upward, metal shrieking as the main spar failed catastrophically. The bomber entered an uncontrollable spin, falling toward the grey waters below with no possibility of recovery. 9 American airmen died in those few seconds, victims of a weapon that would prove more effective against heavy bombers than anything the Luftwaffe had previously deployed. Bär had just experienced the combat debut of Germany's most successful aircraft cannon of World War II, a weapon so effective that American bomber crews would learn to fear its distinctive muzzle flash, so reliable that German pilots trusted it above all other armament, and so devastating in its impact that it would destroy more Allied aircraft than any other German cannon type. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Yet the MG-151/20 cannon's story reveals a bitter irony that haunted German aviation throughout the war. By the time this devastating weapon reached full production and deployment, the strategic situation had shifted so dramatically that individual weapons' excellence could no longer compensate for overwhelming Allied numerical superiority and industrial capacity. The story of Germany's bomber killer begins not with dramatic combat encounters, but in the sterile offices of the German Aviation Ministry in Berlin during the late 1930s. Luftwaffe technical officers, analyzing combat reports from the Spanish Civil War where German fighters had first encountered modern bombers in significant numbers, reached troubling conclusions about their existing armament. The standard fighter cannon of 1938, the MG-FF, fired 20mm shells at approximately 520 rounds per minute. While effective against lightly built aircraft like the Soviet fighters encountered in Spain, the MG-FF proved marginal against larger, more robust bombers. Multiple hits were required to bring down aircraft that could absorb substantial damage and continue flying. German pilots reported frustrating encounters where they would score visible hits on enemy bombers, see pieces flying off and smoke trailing, yet watch their targets continue toward their objectives. The lightweight shells fired by the MG-FF often lacked sufficient kinetic energy to penetrate deeply into bomber structure or cause catastrophic system failures. More critically, the MG-FF's relatively slow rate of fire meant that fighter pilots had limited opportunities to achieve multiple hits during the brief engagement windows that characterized high-speed air combat. In the few seconds available for an attack run before needing to break away to avoid collision or defensive fire, the cannon might fire only 10 to 15 shells. Even with perfect accuracy, which was rare under combat conditions, such limited shell delivery proved insufficient against large, rugged bombers, designed to absorb battle damage. The Spanish experience convinced German aviation planners that future fighter armament needed substantial improvement in both hitting power and rate of fire. The development contract for an improved aircraft cannon went to Mauser Werke AG, a company with extensive experience in automatic weapons design dating back to World War I. Mauser's engineers faced specific requirements that would challenge conventional cannon design philosophy. The new weapon needed to fire 20mm ammunition for compatibility with existing logistics systems. It required a rate of fire exceeding 700 rounds per minute, substantially higher than existing designs. The cannon had to maintain reliability under the extreme conditions of fighter aircraft operations, including high G-forces, temperature variations from -40°C at altitude to +40° on the ground, and vibration levels that would destroy less robust mechanisms. Weight limitations imposed by fighter aircraft design meant the entire cannon system, including ammunition feed mechanisms, could not exceed existing installations significantly. The weapon needed to function effectively with the high-velocity ammunition that German ordnance designers were developing specifically for anti-bomber use. Mauser's response was the MG-151, a weapon that would become the foundation for multiple variants tailored to different applications. The basic design featured an electrically operated firing mechanism that provided the consistent timing necessary for high rates of fire. Advanced metallurgy created barrel assemblies capable of withstanding the thermal and mechanical stresses of sustained rapid fire. Precision manufacturing achieved tolerances that ensured reliable function despite the brutal operating environment of fighter combat. Most importantly, the weapon's design incorporated lessons learned from extensive analysis of aerial combat, optimizing every component for the specific demands of air-to-air engagement against heavily defended bomber formations. The 15mm variant, designated MG-151/15, entered service first in 1941. This version provided increased rate of fire and improved reliability compared to the older MG-FF, but still used relatively lightweight ammunition that limited its effectiveness against large bombers. Combat experience during the early phases of the air war over Britain revealed that while the MG-151/15 represented a significant improvement over previous weapons, it still required multiple hits to destroy modern bombers reliably. German fighter pilots reported the same frustration they had experienced with earlier armament. They could achieve hits, they could cause visible damage, but bringing down a flying fortress or consolidated liberator still demanded sustained attacks that exposed them to devastating defensive fire from bomber formations. The solution lay in scaling up the successful MG-151 design to handle 20mm ammunition with substantially improved ballistic characteristics. The MG-151/20 cannon that Hauptmann Bär fired that October morning in 1942 represented the culmination of German aircraft cannon development. Every component had been optimized for maximum effectiveness against large, rugged bomber aircraft. The weapon's electric firing mechanism provided precise timing that enabled the 800 rounds per minute rate of fire that distinguished it from all previous German cannon types. This dramatically increased rate meant that during a typical 3-second attack run, the cannon could deliver 40 shells instead of the 26 that earlier weapons might achieve. The barrel assembly used advanced steel alloys that could withstand the increased thermal load generated by rapid fire without accuracy, degradation, or premature wear. Precision rifling ensured that high-velocity shells maintained optimal ballistic characteristics throughout their flight path, maximizing both accuracy and terminal effectiveness. The ammunition feed system handled the increased cyclic rate without jamming, a critical improvement over earlier designs that had frustrated pilots with stoppages during crucial combat moments. Most importantly, the weapon was designed specifically for the new generation of 20mm ammunition that German ordnance engineers had developed for anti-bomber use. These shells featured substantially increased muzzle velocity compared to earlier types, typically around 850 meters per second compared to 700 meters per second for older ammunition. Higher velocity translated directly into increased kinetic energy upon impact, enabling the shells to penetrate deeper into bomber structure and cause more extensive damage. The new ammunition also incorporated improved explosive fillings and more sensitive fusing that ensured reliable detonation even when striking relatively thin aluminum skin. Each shell carried sufficient explosive power to destroy critical aircraft systems or structural components with a single hit, provided the impact occurred in a vital area. The combination of increased rate of fire, higher velocity ammunition, and improved explosive effectiveness transformed the tactical equation of bomber interception. Where previous weapons had required sustained attacks to achieve bomber kills, often exposing the attacking fighter to prolonged defensive fire, the MG-151/20 could potentially destroy a bomber with a single well-placed burst. This capability would prove decisive in the type of hit-and-run attacks that offered German fighters their best chance of survival against the increasingly sophisticated defensive formations that American bomber units developed through painful combat experience. The first operational MG-151/20 cannons reached frontline Luftwaffe units in late summer 1942, initially equipping the new Focke-Wulf 190 fighters that were beginning to replace aging Messerschmitt Bf-109s in air defense roles. The FW-190's robust airframe could accommodate the new cannon's greater size and weight, while providing a stable firing platform that maximized the weapon's accuracy potential. Early combat reports from pilots transitioning to the new armament revealed immediate and dramatic improvements in anti-bomber effectiveness. Where previous engagements might require multiple attack runs to achieve a single bomber kill, pilots armed with MG-151/20 cannons reported destroying bombers with single passes, provided they achieved accurate hits on vital areas. The psychological impact on German fighter pilots was profound and immediate. For the first time since the strategic bombing campaign had begun in earnest, they possessed a weapon that gave them confidence in their ability to stop the massive formations of flying fortresses and liberators that appeared over Germany with increasing frequency. Hauptmann Heinrich Bär, the pilot who had experienced the cannon's combat debut over the English Channel, became one of its most vocal advocates within the Luftwaffe fighter community. In post-mission reports filed throughout late 1942 and early 1943, Bär documented the weapon's devastating effectiveness against American heavy bombers. His detailed accounts, preserved in Luftwaffe archives discovered after the war, provide unique insight into how the new cannon changed the tactical balance of air combat over Western Europe. Bär noted that the MG-151/20's rapid rate of fire allowed him to place multiple shells into bomber formations before defensive gunners could track his aircraft effectively. The brief engagement windows that characterized fighter attacks on bomber formations, typically 2 to 4 seconds from optimal firing range until the need to break away, could now deliver enough shells to cause catastrophic damage to bomber structure or systems. Previous weapons might achieve 6 to 8 hits during such brief attacks, often insufficient to bring down large bombers immediately. The MG-151/20 could deliver 15 to 20 shells in the same time period, virtually guaranteeing critical damage if the attack was pressed home with accuracy and determination. The weapon's reliability under combat conditions impressed pilots who had experienced frustrating cannon jams with earlier armament types. The MG-151/20's electrically operated mechanism proved far more consistent than the older pneumatic and mechanical systems, functioning reliably even under the extreme G-forces and vibration levels generated during violent combat maneuvering. This reliability encouraged more aggressive tactics, as pilots could count on their primary armament functioning when needed most. Combat reports from the winter of 1942 through 1943 documented steadily improving kill-to-sortie ratios for units equipped with the new cannon. The 8th Air Force, conducting its own analysis of German fighter effectiveness during this period, noted a disturbing trend in bomber loss rates that corresponded directly with the deployment timeline of the MG-151/20 cannon. American intelligence officers, analyzing wreckage of shot-down bombers and interviewing surviving crew members, identified the characteristic damage patterns created by the new German weapon. The high-velocity 20mm shells produced distinctly different damage signatures compared to earlier German armament. Where previous cannon shells might create relatively small entry holes with limited internal damage, the MG-151/20 shells punched large holes through aluminum skin, continued through internal structure with devastating effect, and often exited through the opposite side of the aircraft after destroying everything in their path. Multiple hits in critical areas such as wing spars, control cables, or engine mounts could cause immediate structural failure that gave bomber crews no opportunity for emergency procedures or bailout attempts. The weapon's effectiveness forced American planners to reconsider bomber formation tactics and defensive procedures. The tight defensive boxes that had proven effective against earlier German weapons became increasingly vulnerable to fighters armed with the devastating new cannon. Single attacking fighters could now potentially destroy multiple bombers during a single pass through the formation if conditions allowed sustained, accurate fire. This capability encouraged German pilots to press attacks more aggressively, accepting higher risks in exchange for the increased probability of achieving multiple kills per sortie. The tactical revolution initiated by the MG MG-151/20 cannon extended beyond simple improvements in anti-bomber effectiveness. The weapon's rapid rate of fire and devastating hitting power changed fundamental aspects of air-to-air combat tactics throughout the European theatre. German pilots armed with the new cannon could engage Allied fighters with unprecedented confidence, knowing that even brief bursts could cause critical damage to enemy aircraft. This advantage proved particularly significant against the rugged American fighters like the Republic P-47 Thunderbolt that had frustrated German pilots with their ability to absorb substantial damage and continue fighting. The MG-151/20's high-velocity shells could penetrate the P-47's armor and cause critical system failures that earlier weapons had been unable to achieve consistently. Combat reports from early 1943 documented numerous instances where single cannon bursts disabled or destroyed American fighters that had previously proven nearly invulnerable to German armament. The psychological effect on both sides was immediate and profound. German pilots reported increased confidence and more aggressive tactics, while American fighter pilots began reporting encounters with German cannon fire that seemed far more destructive than previous engagements. The weapon's impact extended beyond individual combat encounters to influence broader strategic planning on both sides. German fighter commanders, recognizing the potential of their new armament, began developing tactics specifically designed to maximize the MG-151/20's effectiveness against bomber formations. These new approaches emphasized precision attacks on critical bomber systems rather than the sustained fire that previous weapons had required. The high rate of fire and devastating terminal effectiveness meant that brief, accurate attacks could achieve the same results that had previously required prolonged exposure to defensive fire. This tactical evolution reduced German fighter losses while simultaneously increasing bomber destruction rates, creating a temporary shift in the aerial balance over Western Europe. American bomber commanders, faced with increasing loss rates that threatened the viability of daylight strategic bombing, implemented changes to formation tactics, defensive procedures, and escort coordination specifically designed to counter the new German cannon threat. The deadly effectiveness of the MG-151/20 forced innovations in bomber design, crew training, and mission planning that would influence American air operations for the remainder of the war. Yet, even as the new cannon achieved unprecedented success against Allied bombers and fighters, German aviation planners understood that individual weapons superiority could not compensate for the broader strategic challenges facing the Luftwaffe. The industrial capacity that produced American bombers and fighters far exceeded Germany's ability to manufacture fighter aircraft, regardless of how effective those fighters' armament might be. The MG-151/20 could destroy any Allied aircraft it hit with devastating efficiency, but German factories could not produce enough fighters armed with the cannon to stop the growing streams of bombers appearing over Germany. Production statistics from German aircraft manufacturers during 1943 revealed the scale of this challenge. While the MG-151/20 represented a quantum leap in anti-bomber capability, German industry could not manufacture enough cannons, enough fighters to mount them, or enough ammunition to sustain the rates of combat required to stop the Allied bombing campaign. The weapon's very effectiveness created logistical challenges that German planners had not fully anticipated. The high rate of fire that made the cannon so deadly against bombers also meant that fighter aircraft expended ammunition far more rapidly than previous weapons. Standard ammunition loads that might sustain multiple combat engagements with older cannons could be exhausted in single encounters with the MG-151/20. This demanded increased ammunition production, more frequent rearming of fighter aircraft, and logistics systems capable of supporting the massive shell consumption rates generated by rapid-fire cannon. German ammunition factories, already strained by the demands of multi-front warfare, struggled to meet the increased demand for 20mm cannon shells. The specialized high-velocity ammunition required for optimal MG-151/20 performance demanded precision manufacturing and quality materials that were becoming increasingly difficult to obtain as the war progressed. Strategic bombing of German industrial targets by the same Allied bombers that the cannon was designed to destroy created a vicious cycle where weapons production fell even as the need for those weapons increased. The irony was not lost on German planners, who understood that they were fighting a war of industrial attrition that they could not win regardless of tactical advantages. By spring 1943, the MG 151/20 cannon had proven itself beyond any doubt as the most effective anti-bomber weapon in the German arsenal. Combat reports from across the European theatre documented kill ratios that far exceeded anything achieved with previous armament. Individual pilots armed with the cannon consistently destroyed multiple bombers per mission when conditions allowed successful attacks. The weapon's reliability under combat conditions had eliminated the jamming problems that had plagued earlier German cannon, allowing pilots to press attacks with confidence in their armament. The devastating terminal effectiveness of the high-velocity 20mm shells meant that accurate hits virtually guaranteed bomber destruction, eliminating the frustrating encounters where pilots achieved multiple hits without bringing down their targets. Yet the strategic situation continued, deteriorating despite these tactical successes. American bomber production accelerated throughout 1943, replacing losses faster than German fighters could inflict them, regardless of individual weapon effectiveness. The escort fighters that accompanied bomber formations grew more numerous and capable, neutralizing many of the tactical advantages that the MG 151/20 provided to German interceptors. Most critically, the Luftwaffe's pilot training programs could not replace experienced fighter pilots faster than combat attrition claimed them. Even with superior weapons, inexperienced pilots achieved far lower success rates than veterans who understood how to exploit the cannon's capabilities effectively. The mathematical reality of aerial warfare meant that individual weapons' excellence could not compensate for systematic disadvantages in numbers, production capacity, and pilot replacement rates. The summer of 1943 would bring the most intensive phase of the air war over Europe, with massive Allied bombing campaigns striking deep into Germany, while the Luftwaffe threw everything available into the defense of critical industrial targets. August 17, 1943. Schweinfurt, Germany. Major Egon Meyer, commander of the 3rd Group of Jagdgeschwader II, positioned his Focke-Wulf 190 at 28,000 feet, watching the largest formation of American bombers yet assembled approach the ball-bearing factories that were critical to German war production. 376 Boeing B-17s, flying in tight defensive boxes stretched across miles of German airspace, their synchronized engines creating a thunderous drone that could be heard on the ground. Each bomber carried approximately 4,000 pounds of high-explosive and incendiary bombs, targeted at the factories that produced 60% of Germany's ball bearings. Meyer's fighter carried 4 MG 151/20 cannons, the heaviest concentration of the devastating weapon yet mounted in a single aircraft. The installation had required significant modifications to the FW-190's wing structure, but combat testing had proven that the increased firepower more than compensated for the weight penalty and reduced ammunition capacity. What happened during the next 45 minutes would demonstrate both the extraordinary effectiveness of the MG 151/20 cannon and the mathematical impossibility of stopping the Allied bombing campaign through fighter interception alone, regardless of weapons superiority. Meyer's initial attack run targeted the lead bomber in a 3-aircraft element flying at the formation's front edge. Diving from the sun, he opened fire at 400 yards, watching his cannon shells streak toward the flying fortress in a concentrated stream that previous German weapons could never have achieved. The rate of fire was so rapid that individual shells blurred into what appeared to be a solid beam of destruction. In the 3 seconds between optimal firing range and mandatory breakaway to avoid collision, Meyer's 4 cannons delivered 96 20mm shells, more than most German fighters had carried as their total ammunition load just 2 years earlier. The effect was catastrophic and immediate. The B-17's port wing separated at the root, severed by multiple shell hits that destroyed the main spar. The bomber rolled inverted and entered an unrecoverable spin, its crew having no opportunity to bail out before impact. 9 American airmen died in those seconds, killed by a weapon system that could destroy any aircraft it hit with devastating certainty. Meyer continued his attack, using the energy from his initial dive to climb back to altitude for a second pass. The MG-151/20's reliability allowed him to engage multiple targets without concern for weapon malfunctions that had plagued earlier German armament. His second attack targeted a bomber flying in the formation's lower element, approaching from below and behind where the flying fortress's defensive firepower was concentrated in the ball turret and tailgun positions. The cannon shells punched through the bomber's aluminum skin as if it were paper, continuing through internal structure to detonate against engines, fuel tanks, and control systems. The B-17's starboard engines caught fire immediately. Fuel lines severed by shell fragments fed the flames, which spread rapidly along the wing despite the self-sealing fuel tanks that had saved so many American bombers from earlier German weapons. The crew bailed out as their aircraft began its death spiral toward the German countryside below. In less than 10 minutes, Bär had destroyed 2 heavy bombers using tactics that would have been impossible with previous German armament. The MG-151/20's combination of rapid fire rate and devastating terminal effectiveness allowed single fighters to achieve kill ratios that earlier weapons could only dream of accomplishing. Yet, even as individual German pilots achieved unprecedented success, the broader tactical situation revealed the weapon's strategic limitations. The Schweinfurt raid involved 376 bombers escorted by hundreds of fighters. German defenders could field approximately 250 fighters of all types, and many of those were older aircraft armed with less effective weapons. Even if every German fighter achieved multiple bomber kills, Molex, an impossible standard that no air force in history had ever approached, the mathematical reality remained daunting. The Americans could replace their losses within weeks using their massive industrial capacity, while German fighter losses were becoming increasingly difficult to replace as pilot training programs struggled to keep pace with combat attrition. Major Walter Dahl, flying with Jagdgeschwader 3, experienced the weapon's effectiveness and its limitations during the same Schweinfurt mission. His FW-190 carried 2 MG-151/20 cannons supplemented by machine guns, a mixed armament that provided flexibility for different target types. Dahl's attack on a bomber formation from the 91st Bomb Group resulted in 3 confirmed kills in a single pass, an achievement that would have been virtually impossible with earlier German weapons. The cannon shells tore through bomber formations with such devastating effect that surviving American crew members later described the experience as flying through walls of explosive death. But Dahl's success came at a cost that highlighted the weapon's strategic limitations. The high rate of fire meant that his ammunition was exhausted after 2 attack passes, forcing him to disengage from combat while dozens of bombers continued toward their targets. Earlier, German weapons, while less effective per shell, could sustain longer engagements due to their slower fire rates. The MG-151/20's very effectiveness created tactical dilemmas that German planners had not fully anticipated. The ammunition consumption rates generated by the rapid-fire cannon demanded fundamental changes to German logistics systems. Fighter units equipped with the weapon required 3 times the ammunition supplies of units using older cannons, straining supply lines that were already stretched by multi-front warfare and Allied interdiction of transportation networks. Ground crews discovered that aircraft armed with MG-151/20 cannons needed rearming after every mission, compared to earlier weapons that might sustain multiple sorties on a single ammunition load. This increased turnaround times, reduced sortie rates, and placed additional strain on maintenance personnel who were already working around the clock to keep German fighters operational. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The quality of German 20mm ammunition began declining through 1943 as raw material shortages and bombing of manufacturing facilities affected production standards. The MG-151/20's devastating effectiveness depended on high-velocity shells with precise manufacturing tolerances and consistent explosive filling. As German industry struggled to maintain these standards, pilots reported increasing numbers of duds, shells that failed to detonate upon impact, and ammunition with inconsistent ballistic characteristics that affected accuracy at longer ranges. Combat reports from late 1943 documented growing frustration among pilots who achieved perfect hits, only to watch shells bounce off bomber armor or pass through fuel tanks without causing fires. The weapon system's superiority was being undermined by industrial degradation that reflected Germany's deteriorating strategic position. The psychological impact of the MG-151/20 on Allied bomber crews was profound and immediate. American airmen who survived encounters with the devastating cannon described the experience in terms that revealed its terrorizing effectiveness. Technical Sergeant James Murphy, ball turret gunner with the 306th Bomb Group, survived a mission where his B-17 absorbed multiple hits from MG-151/20 fire. His post-mission report, preserved in Air Force archives, provides unique insight into the weapon's impact from the receiving end. The German fighter came at us head-on, and I could see his cannon firing. But it wasn't like the older guns where you'd see individual muzzle flashes. This looked like a solid stream of fire, like someone was spraying us with a hose made of explosions. When the shells hit, they didn't just make holes. They tore chunks out of our aircraft. I watched our port engine disintegrate in seconds. If our pilot hadn't taken violent evasive action, we would have been dead in the air. Murphy's bomber made it back to England despite catastrophic damage that would have been impossible to survive with earlier German weapons. The MG-151/20 had missed critical structural components by inches, demonstrating both its devastating potential and the role that luck continued to play in aerial combat, regardless of weapons' effectiveness. American bomber commanders, analyzing loss patterns and damage reports, quickly identified the signature effects of the new German cannon. The distinctive damage patterns created by high-velocity 20mm shells allowed intelligence officers to track the weapon's deployment across German fighter units and assess its impact on mission effectiveness. The 8th Air Force's loss rate increased measurably during periods when German units equipped with MG-151/20 cannons were most active. However, American production capacity meant that these losses, while painful in human terms, did not threaten the strategic bombing campaign's continuation. German fighter pilots, armed with the devastating cannon, achieved individual success rates that exceeded anything previously accomplished in aerial warfare. Oberst Johannes Steinhoff, flying with Jagdgeschwader 7, scored 14 bomber kills in a single month, using tactics specifically developed to exploit the MG-151/20's rapid-fire capability. Steinhoff's approach involved attacking bomber formations from angles that maximized his cannon's effectiveness while minimizing exposure to defensive fire. He would position his aircraft to engage multiple bombers during a single pass, using the weapon's 800 round per minute rate of fire to spray shells across entire elements of the formation. Combat camera footage from Steinhoff's aircraft, recovered after the war, shows the devastating effect of concentrated MG-151/20 fire on bomber formations. Individual 3-second bursts could disable or destroy multiple aircraft as shells passed through one bomber to strike others flying in close formation. Yet even Steinhoff's remarkable success rate could not change the strategic mathematics that determined campaign outcomes. For every bomber he destroyed, American factories completed 3 more. For every mission he flew, American training programs graduated 10 new bomber crews. The individual excellence that the MG-151/20 enabled could not compensate for systematic disadvantages in industrial capacity and manpower replacement that characterized Germany's strategic position by late 1943. Major Heinrich Bär, the pilot who had first experienced the cannon's effectiveness over the English Channel, became the Luftwaffe's most successful user of the weapon system. By early 1944, he had achieved over 40 bomber kills using MG-151/20 armament, making him one of the most successful anti-bomber specialists in aviation history. Bär's tactical innovations influenced German fighter doctrine throughout the European theatre. He developed attack profiles that maximized the cannon's rapid-fire advantage while minimizing exposure to defensive fire from bomber formations and escort fighters. His preferred approach involved diving attacks from high altitude that built up speed for rapid disengagement, using the MG-151/20's devastating firepower to achieve kills during brief engagement windows that gave defensive gunners minimal time to track and engage his aircraft. Bär's post-mission reports documented the weapon's extraordinary reliability under combat conditions. Unlike earlier German cannons that frequently jammed during violent maneuvering, the MG-151/20 functioned consistently even under extreme G-forces and temperature variations. This reliability encouraged more aggressive tactics that would have been suicidal with less dependable weapons. Pilots could commit to attacks knowing their primary armament would function when needed most, a psychological advantage that translated into improved combat effectiveness. But Bär also documented the weapon's strategic limitations in reports that revealed growing pessimism among frontline pilots. Despite achieving unprecedented individual success rates, German fighter units were being overwhelmed by sheer numbers of Allied aircraft that exceeded any possibility of successful interception. The MG-151/20 could destroy any bomber it hit, but German fighters couldn't be everywhere simultaneously. American formations increasingly flew multiple simultaneous raids that scattered German defenses across hundreds of miles of airspace. Even perfect weapons employed by skilled pilots could not overcome the mathematical reality of being outnumbered 10-1 by enemies with unlimited replacement capacity. The weapon's very effectiveness highlighted the futility of Germany's strategic position, rather than offering hope for reversing unfavorable trends. February 20th, 1944, the beginning of Big Week, the Allied operation designed to destroy German fighter production through coordinated bombing of aircraft factories. Over 3,000 Allied bombers and fighters participated in the largest air campaign yet mounted, striking targets across Germany and Austria. Hauptmann Georg Peter Eder, flying with Jagdgeschwader 1, led a formation of 12 Fw-190s armed with MG-151/20 cannons against a stream of B-17s approaching the Messerschmitt factory complex at Regensburg. What he witnessed during the next hour would crystallize the fundamental contradiction that defined the MG-151/20's wartime service. Eder's first attack achieved everything German tactical doctrine promised. Approaching a 3-aircraft bomber element from the sun, his cannon fire destroyed the lead B-17 in seconds, watching the massive aircraft disintegrate under the impact of shells delivered at 800 rounds per minute. The 2 remaining bombers in the element took evasive action, but Eder's wingman pressed his own attack, achieving a second kill before the formation could reorganize. In less than 30 seconds, 2 of Germany's most devastating weapons had eliminated 6% of the attacking bomber element. This level of effectiveness exceeded anything achieved with previous German armament. The MG-151/20 had proven capable of stopping bomber formations if employed by skilled pilots in sufficient numbers with adequate ammunition supplies. But as Eder climbed for his second attack, the strategic reality became undeniable. His 12 fighters faced over 200 bombers protected by an equal number of escort fighters. Even if every German pilot achieved multiple kills, EI-1, a standard that no air force had ever approached, they could destroy perhaps 20% of the attacking formation. The remaining bombers would continue to their targets, drop their bombs, and return to England where they would be repaired or replaced within days. Meanwhile, German aircraft losses were becoming irreplaceable as factories fell behind production schedules due to material shortages and bombing damage. Eder's second attack run brought him into contact with P-51, Mustang escorts that had learned to counter German tactics through bitter experience. The American fighters, armed with 6 50-caliber machine guns each, could not match the devastating hitting power of the MG-151/20, but they possessed numerical superiority and unlimited replacement capacity. The ensuing dogfight demonstrated both the cannon's effectiveness and its irrelevance to strategic outcomes. Eder achieved 2 fighter kills using brief bursts that would have been impossible with earlier weapons, but his ammunition was exhausted after 3 engagement sequences. He was forced to disengage while dozens of enemy aircraft remained in the area, returning to base to rearm while the bombers continued unmolested toward their targets. The weapon that could destroy anything it hit could not be everywhere simultaneously, and numerical inferiority made comprehensive defense impossible, regardless of individual weapons' effectiveness. The Regensburg raid inflicted serious damage on Messerschmitt production facilities despite determined resistance from fighters armed with Germany's most effective anti-bomber weapon. The mathematical reality was inescapable. American industrial capacity could replace losses faster than German fighters could inflict them, creating a strategic equation that individual weapons excellence could not solve. German pilots returning from big week missions filed reports that documented both triumph and despair. They had achieved individual success rates unprecedented in aerial warfare history, destroying bombers and fighters with efficiency that validated every technical specification the MG-151/20's designers had promised. Yet they had failed to stop the bombing campaign that was systematically destroying Germany's ability to continue the war. The very factories that produced their devastating cannons lay in ruins, bombed by the aircraft those cannons had been designed to destroy. The irony was profound and demoralizing. Germany's most effective anti-bomber weapon was proving strategically irrelevant because the bombers it was designed to stop were destroying the industrial capacity needed to produce the weapon in decisive quantities. Major Walter Nowotny, one of Germany's highest-scoring aces with over 250 confirmed victories, experienced this contradiction firsthand during operations against American bomber formations in spring 1944. Flying an Mi-2-62 jet fighter, armed with 4 MG-151/20 cannons, he possessed the most advanced weapons platform in the German arsenal. The jet's speed allowed attack profiles impossible with conventional fighters, while the concentrated cannon firepower could destroy multiple bombers during single attack runs. Nowotny's first encounter with B-17s while flying the Mi-2-62 resulted in 4 confirmed kills in less than 2 minutes, a rate of destruction that seemed to offer hope for reversing unfavorable strategic trends. But Nowotny's success revealed the weapon's ultimate limitations rather than its potential for strategic impact. His jet fighter was one of perhaps 20 operational aircraft of its type, compared to thousands of Allied bombers that appeared over Germany with increasing frequency. Even perfect weapons employed by exceptional pilots could not overcome numerical disadvantages of 50-1 or greater. The Mi-2-62 program, despite its revolutionary technology and devastating armament, produced too few aircraft too late to influence strategic outcomes. Nowotny would be killed in November 1944 when his jet fighter suffered engine failure during takeoff, highlighting the technological challenges that prevented German advanced weapons from achieving mass production necessary for strategic impact. The summer of 1944 brought the most intensive bombing campaign yet mounted against Germany. Operation Point Blank targeted oil production facilities, transportation networks, and remaining aircraft factories with relentless precision. German fighter units equipped with MG-151/20 cannons achieved tactical successes that exceeded every performance parameter their weapons had been designed to meet. Individual pilots consistently destroyed multiple bombers per mission when ammunition supplies and tactical conditions allowed optimal employment. The cannon's reliability and devastating effectiveness had eliminated most technical limitations that had frustrated earlier German armament. But strategic success remained impossible due to numerical disadvantages that no amount of individual weapons excellence could overcome. American bomber formations grew larger and more frequent, while German fighter strength declined due to pilot losses that could not be replaced at sustainable rates. The MG-151/20 had given German pilots the most effective anti-bomber weapon in aviation history, but it could not give them enough aircraft, enough pilots, or enough ammunition to stop an enemy with unlimited industrial resources and replacement capacity. April 25, 1945. Rechlin Test Center, Germany. Hauptmann Hans-Werner Lerche walked among the wreckage of what had once been the Luftwaffe's premier aircraft evaluation facility. Allied bombing had reduced the complex to rubble and twisted metal, but scattered among the debris lay examples of the MG-151/20 cannon that had once represented Germany's hopes for achieving air superiority through superior weapons technology. The cannons, stripped from destroyed aircraft and abandoned in the chaos of Germany's final collapse, bore silent witness to one of aviation history's most profound ironies. They remained functionally perfect, capable of destroying any aircraft they encountered, yet strategically irrelevant to a war that had been decided by industrial mathematics rather than individual weapons excellence. Lerche, one of Germany's most experienced test pilots who had evaluated virtually every aircraft type that fell into German hands during the war, understood the bitter lesson that the MG 151/20's service history had taught. Tactical superiority meant nothing without strategic depth. The best weapons in the world could not compensate for fundamental disadvantages in production capacity, pilot training, and resource availability. The final months of the European war had seen German pilots achieve individual success rates with the MG 151/20 that exceeded every performance specification the weapons designers had envisioned. Single fighters could destroy entire bomber elements during brief attack runs, demonstrating firepower concentration that would have seemed impossible just years earlier. Yet these tactical victories occurred within the context of strategic defeat so complete that individual weapons effectiveness became meaningless. By early 1945, the Luftwaffe could field fewer operational fighters than the Allies lost in routine training accidents, despite possessing armament that was superior to anything in Allied arsenals. The story of the MG 151/20's final operational period reveals how technological excellence became divorced from strategic relevance as Germany's war-making capacity collapsed under sustained Allied pressure. Even perfect weapons could not function without fuel, ammunition, spare parts, and trained personnel to operate them. Major Erich Hartmann, the highest-scoring fighter ace in aviation history with 352 confirmed victories, flew his final combat missions in early 1945 with an aircraft armed with MG 151/20 cannons. His post-war reflections on the weapon's capabilities and limitations provide unique insight into its ultimate significance. The MG 151/20 was everything we had hoped for in an aircraft cannon, Hartmann recalled in interviews conducted decades after the war. It was reliable, devastating, and gave us confidence that we could destroy any aircraft we encountered. But by 1945, it didn't matter how effective our weapons were. We had perhaps 20 fighters available for missions while the Allies could put up 2,000. Perfect weapons operated by skilled pilots cannot overcome such numerical disadvantages. Hartmann's assessment captured the essential tragedy of German aviation in the war's final phase. The MG 151/20 represented the pinnacle of aircraft armament development, incorporating advanced metallurgy, precision manufacturing, and sophisticated engineering that exceeded anything previously achieved in automatic weapons design. Combat testing had validated every performance characteristic the weapon's specifications promised. The 800 round per minute rate of fire provided devastating volume of shells during brief engagement windows. The high-velocity ammunition ensured reliable penetration of bomber armor and structure. The electric firing mechanism delivered consistent performance under extreme operating conditions. Yet, none of these technical achievements could address the fundamental strategic problems that determined war outcomes. German industry could not produce enough fighters to mount the weapons in decisive numbers. Pilot training programs could not replace experienced aviators faster than combat claimed them. Fuel shortages grounded aircraft regardless of their armament effectiveness. The weapon that could destroy anything it hit became irrelevant when there were insufficient platforms to employ it, and inadequate resources to sustain operations at scales necessary for strategic impact. The MG 151/20's perfect technical performance highlighted the futility of pursuing tactical solutions to strategic problems. Intelligence assessments conducted by Allied forces during Germany's final collapse documented the scope of advanced weapons development that had continued even as the strategic situation became hopeless. Facilities across Germany contained prototypes and production examples of aircraft cannons, rockets, jet engines, and radar systems that exceeded Allied capabilities in specific technical areas. The MG 151/20 represented just one element of a broader German technological effort that had achieved remarkable innovations while failing to influence strategic outcomes. Advanced weapons could not compensate for systematic disadvantages in industrial capacity, resource availability, and strategic position. American and British technical intelligence teams that examined captured German weapons after the war expressed consistent amazement at the engineering sophistication and manufacturing quality they discovered. The MG-151/20, in particular, impressed Allied experts who recognized immediately that it surpassed anything in Western arsenals for anti-bomber capability. Colonel Harold Watson, commanding the United States Air Force's Foreign Technology Division, supervised the evaluation of captured German aircraft weapons during the immediate post-war period. His reports, declassified decades later, provide official assessment of the MG-151/20's technical merits. The German MG-151/20 cannon represents the most advanced aircraft weapon we have encountered, Watson reported to Air Force Headquarters in July 1945. Its rate of fire, reliability, and terminal effectiveness exceed our current 50 caliber machine guns by substantial margins. If the Germans had possessed adequate numbers of aircraft mounting this weapon, along with sufficient fuel and trained pilots to operate them effectively, the strategic bombing campaign would have been far more costly and potentially unsustainable. Watson's assessment acknowledged both the weapon's technical excellence and the strategic factors that had prevented its effectiveness from influencing campaign outcomes. Individual weapons superiority could not overcome systematic disadvantages that characterized Germany's position by the war's final years. The post-war fate of captured MG-151/20 cannons reflected the weapon's technical value, despite its strategic irrelevance to historical outcomes. American, British, and Soviet forces competed to acquire examples for detailed study and reverse engineering, recognizing that the German design incorporated innovations that could influence future weapons development. The United States Air Force's detailed evaluation of the cannon influenced post-war American aircraft armament programs. The rapid-fire capability and devastating terminal effectiveness, demonstrated by the MG-151/20, convinced American planners that future fighter aircraft required similar weapons for effectiveness against jet-powered adversaries. This technical influence extended far beyond simple copying of German innovations. The engineering principles that had made the MG-151/20 effective, high rates of fire, reliable mechanisms, and high-velocity ammunition, ESA, became fundamental design criteria for post-war aircraft weapons development worldwide. The Soviet Union, which had captured substantial quantities of German aircraft weapons along with manufacturing equipment and technical personnel, incorporated MG-151/20 technology into their own post-war cannon development programs. Soviet aircraft weapons of the 1950s and 60s reflected clear influence from German rapid-fire cannon technology. Even the defeated German aviation industry eventually benefited from the MG-151/20's technical legacy. When West Germany was permitted to rebuild its air force as part of NATO during the 1950s, many former Luftwaffe personnel returned to aviation roles, where they applied lessons learned from advanced wartime weapons development. The engineering expertise that had created the MG-151/20 contributed to post-war European aircraft development programs, ensuring that the weapon's technical innovations influenced aviation progress long after its wartime service had ended. Individual German pilots who had employed the MG-151/20 in combat carried their experiences into post-war careers that spanned decades of continued aviation development. Their understanding of advanced weapons employment in high-intensity combat proved valuable during the Cold War period when former enemies became allies facing new threats. Major Johannes Steinhoff, who had achieved remarkable success using MG-151/20 armament against Allied bombers, became a senior commander in the reformed German Air Force during the 1960s. His combat experience with advanced weapons influenced German tactical doctrine and pilot training programs for an entire generation of aviators. The lessons that Steinhoff and other veterans carried forward extended beyond specific weapons employment to broader principles of air combat that remained relevant throughout the jet age. The importance of reliable armament, the need for adequate ammunition supplies, and the requirement for sustained industrial support became fundamental elements of post-war military planning. These veterans understood from direct experience that individual weapons excellence could not compensate for strategic disadvantages, a lesson that influenced NATO planning during the Cold War period when Western forces expected to face numerical disadvantages against Warsaw Pact opponents. The MG-151/20's service history became a case study in military academies and staff colleges worldwide, illustrating how technological superiority could be strategically irrelevant without adequate numbers, logistics support, and industrial capacity to sustain operations at decisive scales. Modern military historians analyzing the weapon's impact have reached consistent conclusions about its significance to World War II's outcome. While the MG-151/20 represented a quantum leap in aircraft armament effectiveness, its deployment came too late and in insufficient quantities to influence strategic results. The cannon's development timeline reflected broader problems with German military procurement that emphasized technical perfection over rapid deployment and mass production. By the time the weapon achieved optimal performance characteristics, Germany's strategic position had deteriorated beyond recovery through tactical innovations. Professor James Coram of the Air University's School of Advanced Air and Space Studies has written extensively about German aviation technology during World War II. His analysis of the MG-151/20's strategic impact emphasizes the timing factors that limited its effectiveness. The Germans achieved remarkable success in aircraft weapons development, producing cannons that exceeded Allied capabilities by substantial margins, Coram observed in his definitive study of Luftwaffe technology. But these weapons reached operational service when Germany could no longer manufacture aircraft in sufficient numbers or train pilots fast enough to achieve strategic impact. Technical excellence became strategically irrelevant. This assessment reflects broader scholarly consensus about the relationship between technological innovation and strategic outcomes during World War II. Individual weapons systems, regardless of their technical merits, could not influence results without adequate supporting infrastructure and strategic context that allowed their employment at decisive scales. The MG-151/20's legacy extends beyond its specific technical achievements to encompass fundamental lessons about military technology development that remain relevant in contemporary defense planning. The weapon demonstrated both the potential and limitations of pursuing technological solutions to strategic challenges. Modern air forces studying historical examples of weapons development consistently examine the MG-151/20 as a case study in how technical excellence must be balanced with production feasibility, logistics support, and strategic timing to achieve meaningful military impact. The United States Air Force's current approach to weapons development reflects lessons learned from German World War II experience, emphasizing rapid deployment and mass production over technical perfection that might delay fielding of adequate quantities. Contemporary aircraft weapons like the 20mm M61 Vulcan cannon trace their design lineage directly to innovations pioneered in the MG-151/20, particularly the emphasis on high rates of fire and reliable electric operation under combat conditions. The Vulcan's 6,000 round per minute rate of fire represents a direct evolution of the rapid-fire concept that made the German cannon so effective, while modern manufacturing techniques allow production in quantities that Germany could never achieve during wartime. This technological continuity demonstrates how the MG-151/20's innovations transcended its immediate strategic context to influence aviation development for generations. The weapon's technical principles proved more enduring than the military organization that created it. The final assessment of the MG-151/20's historical significance must acknowledge both its remarkable technical achievements and its ultimate strategic irrelevance to World War II's outcome. The weapon represented the pinnacle of aircraft armament development during the conflict, incorporating advanced engineering that exceeded Allied capabilities in specific technical areas. German pilots armed with the cannon achieved individual success rates that validated every performance specification the weapon's designers had envisioned. Single fighters could destroy multiple bombers during brief attacks, demonstrating firepower concentration that revolutionized air combat tactics. Yet, these tactical successes occurred within strategic circumstances that rendered individual weapons' effectiveness meaningless. Germany's industrial capacity could not produce enough fighters to mount the weapons in decisive numbers. Pilot training programs could not replace experienced aviators faster than combat claimed them. Most critically, the strategic initiative had passed to enemies with unlimited industrial resources and replacement capacity. The mathematical reality of warfare in the industrial age meant that tactical excellence could not compensate for systematic disadvantages in production, logistics, and strategic position. The MG-151/20 became a symbol of this broader contradiction that characterized German military technology during the war's final phase. Advanced weapons achieved technical perfection while becoming strategically irrelevant due to circumstances beyond their control. The irony was profound and lasting. Germany's most effective anti-bomber weapon could destroy any aircraft it encountered, but it could not destroy enough aircraft to matter when enemies possessed unlimited replacement capacity and the industrial strength to sustain losses indefinitely. The weapon that could have changed tactical outcomes, if deployed in sufficient numbers and supported by adequate logistics, never achieved strategic impact because the conditions necessary for its success no longer existed by the time it reached operational maturity. This historical lesson resonates beyond its specific World War II context to encompass fundamental principles about the relationship between technology and strategy that remain relevant in contemporary military planning. The best weapons in the world cannot compensate for inadequate numbers, insufficient support, or unfavorable strategic circumstances. The MG-151/20 proved this principle through combat service that achieved everything its designers had promised while failing to influence the war's outcome. Its story serves as both a testament to German engineering excellence and a reminder that military technology exists within strategic contexts that ultimately determine its historical significance. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.